In this lesson, we're going to discuss one of my favorite features and topics, pathfinding. Pathfinding is a system in Leadwerks that allows characters to navigate your level and get from one point to another. This is accomplished using something called a navigation mesh. This is in a class called the Navmesh. And we can create these in code. We can also create these in the editor. I'll just show you that real quick. There's my ground. And then select the Navmesh. Create this right in the middle. Now I want to turn on show Navmeshes. And I'm going to say build navigation. There we go. And I just want to show you, it's really cool. I want to show you how this works. I'm going to place a block here. Call build navigation again. And now you can see how it was able to figure out the areas that characters are able to walk in here. In this very simple little scene I put together. You see that? So now, if I place a character, an animated character in here, and I want them to go from here to here, they're going to be able to figure out that they can't go in a straight line. They have to walk around this big wall here. It's a really cool system. Let's take a look at an example in code. Copy that. And then get rid of this. And then we'll just paste this into main.lua. And let's see what the example does. Okay, so when I click somewhere in this scene, this character here, he's going to use the navigation to go to the destination. And if I hold the space key, then I can actually, it will allow me to see what the navigation data actually looks like. So the way I did this is I just called create navmesh, and then I just built it immediately. And this is done after I've set up my little scene, so it just builds the navigation mesh, and then I'm creating my player. Real important, I want to call set nav obstacle false, because this player, it's a cylinder mesh, it has a collider. It's going to affect the navigation mesh if I don't disable that that functionality by calling set nav obstacle to and setting that to false, because navigation meshes are fully dynamic. Now, how I'm actually making this character move around is I call, when the left mouse button is hit, then I'm going to perform a camera pick with the current mouse position, and then if anything is hit, then this agent is going to navigate to that position. I don't have to keep updating its movement every single frame. I just have to tell it once, hey, I want you to navigate to this position, and the pathfinding system will take care of the rest. The agent is created right here. I call create nav agent, and I have to supply the nav mesh that I want that to exist on. And then I'm going to create the player, I'm going to attach the player entity to that navigation agent. A navigation agent is not an entity. I need to attach the player to the agent, and then the entity will just automatically follow that agent. And then I'm just setting the agent's starting position. So I set up the scene just by creating a couple of boxes, and then I created the nav mesh, and this is the result when the navigation mesh is built. And now when I click on here, I'm just telling this agent that the visual entity is connected to, I'm telling it, hey, I want you to navigate over here. And the system takes care of the rest for me. So that's pretty nice, but we can do things that are a lot cooler. Well, before we continue, let's talk about how you get the navigation mesh from a scene. So previously, I started building a map, and in the editor, and I had placed a navigation agent, a navigation mesh in the scene. How would I actually retrieve that if I'm loading the scene from a file? Well, in the entity load script function, the scene is available, the scene object is available, and we can actually access one or multiple Navmeshes using this code right here. We can just say self navmesh equals scene Navmeshes. Most of the time you'll probably just have one Navmesh for the scene, but you could have multiple navigation meshes. If you have multiple navigation meshes, what you might want to do is have a navmesh index integer value exposed in your script that the user can use to decide which navigation mesh to use. But again, that's kind of a rare case. Like most of the time you're just going to have a single navigation mesh. So unless you're doing something special, then you can usually just insert one right here, and that'll be fine for unless you're doing something really special. So the navigation mesh system is fully dynamic without any special code. So all I need to do is I'm just going to copy this code right here, and I'm going to paste this into the main loop. You can paste this anywhere. And now when I press the up and down keys, this wall object that I was using as an obstacle, that's going to move forward and backwards on the z-axis by 1/10 of 1 meter, by 0.1 meters. And I'm going to hold down the space key while I do this so you can see the effect this has. And the navigation data is rebuilding dynamically. And I can even do this as an object is moving. I'm going to try to make him to go this way, and then I'm going to block his path and see what he does. And you see that? He just dynamically decides, okay, well, I can't go that way. I think I'll go the other way. Let's try it again. We'll try to make him go over here. Nope, you're not going that way. Oh! He got away from me. Isn't that cool? And all I had to do there was I just moved this object, and the navigation system just automatically adjusted for me. This is all done on another thread, so it's not going to stall your game. And this just adds so much gameplay because you can have doors that open and close and block paths, and your enemies have to dynamically adjust to the path that they can take. It just really adds a lot of capability and depth to your games. Now, of course, we don't have to just use one object. Besides navigation, we also have crowd handling. So if we have multiple objects like this, there's actually code that will kind of make them act like a flock or a herd. Let's copy this. We'll paste this in. Now we have many objects, and they're all trying to go to the same destination, but they have to also get around each other. And handles that pretty nicely. So this is great for games if you have like a horde of zombies or some other enemy that's just completely overwhelming the player. It'll handle all of that automatically. And all I'm doing is I'm just calling the navigate method here and just telling them all to go to this one spot, and the system handles all the rest of that. Isn't that cool? See, that's all I'm doing. Camera pick, and then I'm just iterating through this array of all the agents, and I'm just telling them all to go to this position, and the system just handles the rest for me. And we have this set up to move that object around, so let's play around with that and see what happens. Oh, not going that way, not going that way, not going that way. Alright, I'll let him go by. Let's try it again. Huh, we have one straggler. So yeah, they're the agents are pretty smart. They'll avoid each other. They'll dynamically adjust to if the scene adjusts. If you have like a bridge that falls down, they'll know that they can go across that bridge once it opens up. So it just really allows a lot of cool things. Okay, this is a nice example. Now, something I want to point out is that the Navmesh, the distance you have here, this is determined by the radius of the nav agents. So, in the create Navmesh function, you have an optional parameter for the radius and the height of the character that's meant to run on that navigation mesh, because that affects how it's built. However, if you have multiple characters of different size, we actually do have a way of handling that, and this example shows it. Let's get rid of all that, paste that in. And the way this is done is by using multiple Navmeshes. So here we have Navmesh 1. We're calling create Navmesh. And then we're creating 10 players on that navigation mesh. And then we have Navmesh 2. And with Navmesh 2, we're doing something a little bit different here. We have a lot of parameters, a lot of optional parameters for this. And one of those parameters is the radius of the agent that's meant to run on it. You can create agents with a radius that doesn't match the Navmesh radius, but you usually don't do that. So up here we didn't specify most of the values, so it's just going to use the default. Here we are specifying a lot of values, and so let's see, we're actually setting the agent radius to 1. Actually, this is the voxel size. This is the agent radius. So a radius of 1 means it's going to be 2 meters in diameter, because radius is just from the center to the outside of the circle. So this one's going to be a little bit bigger, so that means it's going to have a little bit bigger padding around all of these borders here that it forms like this. Then we're going to create the big player, create cylinder, and we're going to use 1 for the radius and 4 for the height. So he's going to be pretty big. And then we're creating this agent that we're calling big agent, and he's created on Navmesh 2, not Navmesh 1. And then we're going to attach the player to the big agent. Okay? We're just going to position it at a random point on the Navmesh 2. Okay? And now, finally, we're going to create another agent, and this is called Big Agent Proxy. And this is going to be created on Navmesh 1. And we're setting the radius to 1. I can actually set that to 4. Doesn't really matter because the height is really already baked into the Navmesh. But we're creating a bigger navigation agent on the first Navmesh. And let's see what we do with that. All we do with that is every frame, we're just going to manually move the big agent proxy to the same position as the big agent. So we're just always going to be forcing that into the same position that the big agent is on Navmesh 2. And so two agents on two different Navmeshes do not see each other. They have no awareness of each other. There's no connection there at all. However, if we create another agent like this on the same Navmesh, on Navmesh 1, that will interact with all of our little agents, our little guys. So let's take a look at the effect of that. There he is. So you can see they're aware of him. They're crowding around him. And we have this small opening here that he cannot fit in in between, but these small characters can fit. And so he's going to take the long way around, and then the small characters are going to take the short way because they can, but they're still going to move out of his way. He's going to kind of push them out of his way. That is pretty interesting. So with this system, you can have one very large character and combined with small characters, and they'll take different routes like this, and yet they'll still collide with each other and get out of each other, try to stay out of each other's way. It's not perfect, but it handles a large number of characters really nicely. See, they'll go right through there. He has to go all the way around. Pretty cool, huh? And it's also simple. You're just calling navigate. This is a little bit more complicated, but I mean, 102 lines of code. There, now it's 100 lines of code. Yeah, that's not too difficult. Okay, now let's have some fun. I have a very special example for you. And this just takes a lot of the ideas that we've learned in this tutorial series and puts them all together. I'm just creating a scene here with a bunch of different, with the ground and a bunch of walls. Then I'm creating a player. He's just going to be a cylinder. I'm going to translate the mesh up a little bit so that the center of the cylinder is at his foot. And I'm going to use player physics for this. I'm going to create a text tile to show the health. I'm going to create another one to show his score, and I'm going to create another one to show the wave number that we're on. Load a sound from our documentation data, and then we have this player take damage function, the player update function, so this gets called every frame, and then we have some bullet handling code, update the camera with a third person view, Handle player movement using the WASD keys. Shooting with the left mouse button like we saw before. Now we're going to create a Navmesh for this scene, and we're going to build it. And we already built all of our scenes, so once we build this, it's done unless something in the scene moves that affects the Navmesh. Now we have a Horde Manager pivot that we're creating. We have this update function. And what this does is this is just checking to see if the zombie table is empty. Then we have this function that called spawn wave, and it accepts a parameter for the count. That's going to be how many zombies are spawned, and then for that many zombies, it's going to create all of them. Each zombie also has another take damage function, so this is an example of having the same function declared two different places, and the bullet code or other code, it doesn't really know or care what the function does. It just looks for it and it calls it if that field exists, and if it's actually a function, then it will call it. We have our zombie update code. This gets called every frame. Let's see. There it is. This is what I'm looking for. Okay, so we're going to get the target using world get entities, and we're looking for any entity with a health value that is greater than 0 and a team that is not equal to self.team, which is the whatever team the zombie is on. So the zombie is saying, if you find some entity that has greater than 0 health and it's not on my team, I am interested in that entity. In this case, it's going to be the player, but if we wanted to add other soldiers or some other kind of NPC, then our zombies would also automatically work for that, as long as the team value was different and the health value was a number greater than 0. So that's how we get our target value that's how the zombie decides what it's going to chase. And then once it has that, then the zombie is going to navigate to the target's position. And then if it gets within a certain distance, then it's going to call the take damage function, and it's going to apply some velocity to the target entity just to push it away so that it's not like constantly attacking it like every single 10 frames in a row. And then our main loop is very simple. We're just going to call the Lua garbage collection function, and then call world update and world render, and that's all there is to it. Let's see what that does. Okay, so I can move with the WASD keys, and I can shoot just by holding the left mouse. Those zombies are using the navigation mesh to chase after me wherever I go. Oh! I wasn't expecting that. They got me a couple of times. Okay, now there's a kind of a lot of... Alright, they got me. So pathfinding is a really important technique, and it makes it really easy to handle pretty intelligent characters that are able to find their way around your level, and they can dynamically adjust as the scene changes. It will handle crowds of enemies, and it will handle enemies of different sizes that can take different pathways. So that's pathfinding.